Okay, so today we're going to try to work on finding trigonometric ratios of special angles. And this is where a lot of our pieces come together. Um, so I'll be saying some very important things that, again, are still laying the foundation for the entire unit circle. So please try to, process these things, think about them. You might want to listen to this video a couple of times so that you can just kind of understand and pull together what it is I'm saying. And we'll talk about this again in class as well. But let's talk first about the quadrantal angles. In our last lesson, we learned that when we are on the unit circle, that we can think of the points on the unit circle as cosine theta, sine theta, okay? Or as the x-coordinate is cosine theta, the y-coordinate is sine theta. Let me back up and explain what a quadrantal angle is. It says a quadrantal angle is an angle whose terminal side lies along one of the coordinate axes. So that means 0, right? At 0, if I have that angle, or we could call it 360 or 2 pi, that's a quadrantal angle because it lies right here on the x-axis. 90 degrees is a quadrantal angle. It's not in quadrant 1, it's not in quadrant 2, it's a quadrantal angle. It's on the axis. Okay, 180 degrees or pi, we say is a quadrantal angle. 270 degrees or 3 pi over 2 is a quadrantal angle. Okay, so that's what we're talking about. How do we evaluate trigonometric functions for this type of angle? So notice, again, if we're on the unit circle, if I go out to 0 degrees or anything that's coterminal to it, again, 2 pi, 4 pi, 8 pi, we've talked about coterminal angles. But when I go out on this axis, my coordinates are 1 and 0. So what that means is cosine of 0 is going to be 0. Okay, and this is not degrees, it's just 0, no units, a real number. Okay, I'm sorry, cosine of 0 is 1. Okay, and then sine of 0 is 0 because here are my coordinates, right? We're looking at this point, and so we've got 1 and 0. So here's my cosine value, here's my sine value. Okay, last time we also learned how we can find the other 4 functions in terms of sine and cosine. So tangent, we said, was sine over cosine. So that's going to be 0 over 1, or just 0. Cosecant is the reciprocal of sine. So that would give us 1 over 0, which is undefined. Okay, I'll just put UND, undefined. All right. Cosecant of 0 has no real number output. All right, secant of 0 is the reciprocal of cosine, so it's just going to be 1 over 1. All right, so just 1. And cotangent of 0 is the reciprocal of tangent, so again we get 1 over 0, or undefined. Okay. All right, so that's it for 0, right? And we need to be comfortable. When I talked about the visualization, if you ask me about cosine of 0 or sine of 0 or any of these functions for 0, in my mind, I kind of visualize this picture, right? And I think about the fact that the coordinates at 0 are 1 and 0, and that this first coordinate gives me my cosine value, and the second coordinate gives me my sine value. Okay, I've got this mental image, all right? And so you need to work on having that mental image along with this knowledge and of course how we define the other functions. Okay, so then let's look at pi over 2, all right? So for pi over 2, the coordinates are 0, 1, okay? Because we're not going left or right, so that's why we have 0 for the first coordinate, and then we just go up to 1, okay? So in that case, that means that cosine of 90 degrees, or pi over 2, is 0, and sine of pi over 2 is 1, okay? And then from there, we can figure out everybody else, okay? For this one, tangent, still sine over cosine. That would give me 1 over 0, so that's undefined. Okay, cosecant is the reciprocal of sine, so we're going to get 1. Secant is the reciprocal of cosine, and so we get undefined. And then cotangent is the reciprocal of tangent. We have undefined, so we might want to go back and say cotangent is cosine over sine. So 0 over 1, which is just 0. Okay. All right, now let's take a look at 180 degrees. Okay, I challenge you to pause the video, think through 180 degrees and 270 degrees, and then play the video again and check to see if you got the answers right. Okay, so for 180 degrees, at pi, I notice I'm going just to the left, right? So that's going to be -1. I'm not going up or down, 0. So that means cosine of pi, or cosine of 180 degrees, is -1. Sine is 0. And so if we do sine over cosine to get tangent, that's going to give me 0, right? 0 over -1. Okay, cosecant is 1 over sine, right? So that's going to be 1 over 0. It's undefined. Okay. Notice I'm not writing equals undefined. Undefined is not a number, right? So you don't say that you're equal to that. And you know, for the most part, it probably won't matter for most of us, but if you plan to go on in mathematics, you don't want to develop a habit of writing equals undefined, because that will be a problem. All right, secant is going to be the reciprocal of cosine. So we're talking about 1 over -1. All right, and cotangent, we've got cosine over sine. So again, -1 over 0. That's undefined. All right. For 270 degrees, okay, I'm going straight down. So we have coordinates of 0, -1. Okay, 0 because we didn't go left or right, and then -1 because we're on that unit circle. We're just going to go down exactly 1 unit. Okay, so that means then that cosine of 3 pi over 2 is 0. And sine of 3 pi over 2 is -1. Okay, tangent is sine over cosine. So we got -1 over 0. It's going to be undefined. Cosecant is the reciprocal of sine, so it's -1. Secant is the reciprocal of cosine. Well, cosine is 0, so if I flip that over, it's undefined. And cotangent is cosine over sine, so we get 0. All right, if you need to, just rewind this and listen to that part again, because it's going to be very important as we go on and build that you are comfortable with that. Okay, so this is not in your notes packet, but this is really, really, really important. So I'm not, as I've already, I think, expressed, I'm really not into memorizing things because, you know, you got to have brain space for all of that, right? And, you know, it's just a lot. But if you can reason things, that usually takes you much farther than knowing one little piece of fact, right? So here's a really powerful tool that's going to help us with knowing those values for our special triangle, okay? So consider this. Let's say we have an angle theta in a right triangle, all right? Then, of course, this is my right angle, all right? The sum of the two acute angles is 90 degrees. So if this is angle theta, then this is going to be 90 degrees minus theta. All right, that's how much that angle is going to measure, all right? Because when I add the two together, I need to get 90 degrees entirely, okay, between these two acute angles. Okay, so let's label our triangle. I'll call this side X. I'm going to call this one Y, and we'll call this R, okay? So if I wanted to talk about sine theta, sine of theta, all right, then based on this picture, it's going to be opposite over hypotenuse, right? So that's Y over R. All right? But notice if I talk about cosine of 90 degrees minus theta, so since we're talking about cosine, that's going to be adjacent over the hypotenuse, also Y over R, okay? These two things are the same, all right? And we want to try to leverage that so that we don't have to remember so much stuff, okay? What's the relationship between theta and 90 degrees minus theta? Okay, they are what we call complementary angles. Okay, you probably studied that in geometry and other places. Complementary angles are angles that add up to 90 degrees. All right, so with complementary angles, you know, again, they add up to 90 degrees, but what we have is our cofunction theorem. If I have complementary angles, the complementary part is why we call these things cofunctions. That co comes from complementary. It wasn't that they couldn't think of any other names for these functions, but that co means something, okay? So let me give you a practical example, and you can see all the identities down here. Let's say theta, just focusing on this first identity, let's say theta is 30 degrees, okay? So I can say then that sine of 30 degrees is equal to cosine of 90 degrees minus 30 degrees, or cosine of 60 degrees. Okay, I don't have to go through all of that little math there. I can easily say 60 degrees and 30 degrees, they're complementary. So sine of 30 degrees is going to be equal to cosine of 60 degrees, okay? I only need to really remember one of these And then if I understand cofunctions, then I've got the rest of it. All right. And it goes on, right? If I say sine 60, well, that's going to be equal to cosine 30. And it holds true for all of them, cotangent and tangent, cosecant and secant. That's what that cofunction means. If you go back and think about some of the things that we've already seen, we saw that sine of 45 degrees was equal to square root 2 over 2. Well, the complement of 45 degrees is 45 degrees, right? So according to this cofunction theorem, we can say that cosine of 45 degrees is also root 2 over 2. And we already know, if we know sine and cosine, we can figure out everything else, right? All right, many examples that we could use like that. Okay, so I hope the point has been made, but let me just give you one more. And it's just not for our special angles, it could be for anything, right? If I knew, let's say, tangent of 50 degrees. I don't know what it is right off the top of my head, but I do know that it's equal to cotangent of 40 degrees. Because 50 and 40 are complementary angles. All right. Okay, so how are we going to use that? If we were on campus, I would give you, as part of a test or a quiz, a blank chart that looked pretty much like this, and give you about 5 minutes to fill it in, okay? Because we really want to know these function values, okay? Now, I remember just a few, okay? Just what I call keystones, all right? And you go back and look at some of the pictures. We've done it twice now of the 30, 60, 90 triangle, okay? But one of the things that I remember from that triangle is that sine of 30 degrees is equal to 1/2, okay? So if I've got sine of 30 degrees is equal to 1/2, then by the cofunction theorem, I also know cosine of 60. Because sine of 30 and cosine of 60 are the same thing. Okay. Now, if you go back and look at that 30, 60, 90 triangle, you'll see that the other value that, kind of alternated for sine and cosine was square root 3 over 2. All right. So sine would be 1/2, and then cosine would be root 3 over 2, or vice versa. They swapped off. Okay. Let me draw the triangle very quickly here. If that's 30 and this is 60, then we got 1, this is 2, this is square root 3, right? That's 60 up there. So if I were talking about cosine of 60, this is 60 right here. Here's my adjacent. There's my hypotenuse. It's 1/2. All right. If we talk about sine of 60, yes, let's talk about sine of 60. Here's 60. Here's my opposite. There's the hypotenuse. So we get root 3 over 2. But that's the same thing as cosine of 30, right? Adjacent over hypotenuse. So root 3 over 2. And if I know these two values, then I know everything else, because I know how to define these functions in terms of sine and cosine. All right, for tangent, if we do sine over cosine, looks like we're going to get 1 over the square root of 3. or root 3 over 3. Cosecant is the reciprocal of sine, so we get 2. Secant is the reciprocal of cosine, so that's going to be 2 over root 3, or 2 root 3 over 3. And cotangent is the reciprocal of tangent. I'm going to take that from right here, so we get just square root 3. All right. But note, if you just say, okay, I'm just going to remember 30 degrees, that's great, right? Because we can take this information still and use that cofunction theorem. We got tangent of 30 degrees. Well, that should be the same thing as cotangent of 60. So root 3 over 3. All right. If we've got cosecant of 30, that should be the same as secant of 60. I know secant of 30, so that's going to be the same as cosecant of 60, 2 root 3 over 3. All right, if I've got cotangent of 30, that's equal to tangent of 60. All right, so pretty much for me, between knowing that sine of 30 degrees is 1/2 and that the other value is root 3 over 2, from there, using the cofunction theorems and the reciprocal identities, the quotient identities that we talked about, we filled out those first 2 lines. Okay. Now, what about for 45 degrees? Well, that one is easy, since 45 degrees is its own complement, right? So if we got 45 degrees, this is the second thing that I remember, that sine of 45 degrees is equal to root 2 over 2. Okay. But because we've got complementary angles, okay, sine and cosine 45 degrees is its own complement. This is also root 2 over 2. And then here we get 1, because we do sine over cosine. All right, I'm going to go ahead and put 1 for cotangent, because it's cosine over sine. All right, and before we rationalize this was 1 over root 2. If you go back to the triangle. And so when I flip it to get cosecant, that's going to be square root 2. And we flip it again, right? Cosine was also 1 over root 2. So we get square root 2 here as well. All right. If you can do this with just a couple of other facts that I'm going to give you, you will know the entire unit circle. All right, but you want to make sure that you've got this, okay? All right, so here's another one of those things that I want to talk about. And that is the signs of the different functions in the different quadrants, okay? So, again, we go back to the fact that on the unit circle, we can think of coordinates as cosine theta, sine theta. And we want to look at this again all the way around the unit circle, but we're going to start here. And what I know about the first quadrant is that in the first quadrant, both x and y are positive, right? So whatever it is I decide to get for cosine, right, my x coordinate is going to be positive in the first quadrant. And for sine is also positive in the first quadrant, all right? So in quadrant 1, sine is going to be positive because we see that, right? Sine takes on the y values. In quadrant 1, y's have to be positive, all right? Cosecant is also going to be positive. So sine and cosecant are positive because they're reciprocals of one another, all right? Cosine is also positive and secant, okay? They're both positive. Okay, we're not dividing here. They're saying cosine and secant, all right? And then tangent and cotangent are both positive. Okay, why? Because we do sine over cosine or cosine over sine. Either way, it comes out to be positive. So in the first quadrant, all of our trigonometric functions are positive. All right, in quadrant 2, we have, I hope you're thinking ahead of me, what kind of x values, what kind of y values? Okay, the x values are going to be negative, and my y values are positive. Okay, so if I think about it still as cosine and sine, all right, then in quadrant 2, sine is positive, but cosine is going to be negative, all right, because that's my x coordinate. And so tangent and cotangent, they're going to be negative, right? When I do positive over negative or negative over positive, that comes out to be negative. Okay. All right, what about quadrant 3? All right, in quadrant 3, I have negative x values and negative y values. All right, so if this is cosine and sine, then that means sine is going to be negative. And of course, it's reciprocal. Cosecant is negative. Cosine is going to be negative. Okay. But a negative over negative gives me positive. So tangent in the third quadrant is going to be positive. All right, and then finally in the fourth quadrant, okay, we've got positive x's and negative y's. So again, this is cosine and sine. All right, and so we get positive for sine. I'm sorry, negative for sine, right? Positive for cosine, right? Because it's the x coordinate. And then tangent is going to be negative. Positive over negative or negative over positive gives me negative. Okay. Now, I'm just going to say one more thing, just for you to begin to ponder. Why is this important? Next week, we'll talk about the reference angle theorem. And basically, what the reference angle theorem says is that if two angles have the same reference angle, then they have the same trigonometric function values, except for possibly plus or minus. Okay? And so let's take, for instance, I kind of jumped ahead a little bit. And while this is here, let me go ahead and say this. We need to remember which functions are positive in which quadrants. So in the first quadrant, all of them are positive. Second quadrant, just sine and cosecant were positive. Third quadrant, tangent was positive. All right, in the fourth quadrant, cosine is positive. There are different mnemonics that will help us remember this, okay, but all students take calculus is one. Okay, it reminds us that in the first quadrant, all of them are positive. In the second quadrant, just sine and its reciprocal are positive. In the third quadrant, tangent is positive. In the fourth quadrant, cosine, its reciprocal, they're positive. Okay? All right, so real quickly, and then I'll be done. In this, let's say this is a 45-degree angle. back to what I was saying about reference angles. Then whoever it is over here that has a reference of 45 degrees, they're going to have the same trigonometric function values as 45 does, right? Except for plus or minus, right? So for instance, we just said sine of 45 degrees is square root 2 over 2. All right. So who is it that has a reference of 45 degrees? Well, hopefully you're thinking 135 degrees, right? So sine of 135 degrees is also going to be the square root of 2 over 2, okay? Why? They have the same reference, and in quadrant 2, I know that sine is positive. Okay, well, what about for cosine? Cosine of 45 degrees is root 2 over 2. Well, what about cosine of 135 degrees? Okay, well, in quadrant 2, cosine is negative. But other than that, because 135 has a reference angle of 45 degrees, we get minus root 2 over 2. Okay, we're going to build on that next week. But for now, what I want you to do is to try to work on the skill that we mentioned earlier, which was, I believe, DPR, finding trigonometric ratios of special angles. Okay, you'll see some of the quadrantal angles that we mentioned. You'll see some of our basic angles, right? And this is something that you really kind of need to work on over and over again. If you've got that table where we were filling it out, I would practice right there, spend some time, if you got blank copies of that or whatever, doing it over and over again. You can make up a little table real quickly and challenging yourself to see if you can fill in the trigonometric function values of 30, 45, and 60, because we'll be building on this. You've got to know this information. But if we know it in the first quadrant, we can take it to quadrants 2, 3, and 4, okay? Again, work on this. If you find that, okay, I'm not really getting it, don't get frustrated. We'll talk about it again in our next class.